Welcome back. So what we're doing today is we're running through a SemiBin2 tutorial. So this is not the first SemiBin tutorial we have on the channel, but I think the other ones are now a little bit out of date because we've released SemiBin2, and even though in fact almost nothing has changed, a few things have, and so just to be sure that people are not afraid to use SemiBin2 because the other tutorial was slightly out of date, just recording, or not recording effectively an updated version. So everything I don't want to show this window and show this window. So everything is in this repository. The link is in the description below as well. And so, and I don't know. And so here we will be following the instructions that are here, and also we will be using the data that is here. So the single sample binning input data is in this subdirectory, and it's actually only two files, which is the assembled data and the sorted BAM file after you map the short reads back to the assembly. So these are the two inputs to SemiBin. So you need to have generated these. So in our case, we generated them with ngLS, although in this example, and it's really just a toy data set. So we actually took a real human gut metagenome and then we just mangled it a bit so that things gonna run pretty fast, but it's not something that you want to be running in for any particular inference, right? So we have other tutorials on how to generate these files, and also I'll mention that next week on April 24th and on May 9th, so if you're watching this soon after I post, then I'm also running a open office hour, so feel free to show up there. Just registration link is below as well, and show up there and ask questions, and we can discuss how this could be generated. So these are the two input files that we're going to be using, so single FASTA and single sorted BAM. So today we're only going to be looking at how to handle the case where you have a single sample that you've assembled into a FASTA file, and then you map the reads as well. All right, so the first thing we do is we're going to create a conda environment. I'm going to call it SemiBin_tutorial. Yes. Okay. And we can activate it. Good. And then I'm going to install. So conda install into this environment, and using the conda forge and the bioconda channels, and I'm going to be installing SemiBin. And okay, so it takes a little bit. Always takes a little bit longer to do things when I'm doing them when I'm recording, because I also have OBS consuming my CPU to do the video and the audio, etc. But so this might take a little bit longer on your side as well, because on your side it will also download all of the packages. So in my case, because I ran through the tutorial before starting the stream, so we it doesn't need to actually download anything, right? So once it installs, it will install the SemiBin2 script. Okay, oh sorry. Yes, and then as I said, so in my case there's no downloading. This just needs to copy things from one directory to another, so it runs quite fast. In your case, you might have to download a bunch of things. And now, so SemiBin works in this command subcommand interface. So let's do the first. We're going to call check install. So SemiBin2 subcommand check install, and it's going to basically quickly check that it has the dependencies it expects, right? So installation okay, and then it will always print that these two citations. We do ask that people cite our papers. This is how we get recognition. So I'm actually going to skip ahead and I'm going to run this in easy mode first. So I copy this. So here again, SemiBin2, the subcommand is single easy bin. So single because it's a single sample, and easy bin because it's a single command that does everything. So we tell it that the environment we're working in is the human gut, and then we give it these two input files, the FASTA file and the BAM file, and we tell it where to write the output. And so in this case, since I ran the tutorial, the output was already there, so it prints a warning that's going to recluster, so it's going to rewrite, but that's okay. This is right. So easy out, there it is, easy out. So a couple of files appear there. So some of them are maybe more useful if you really want to dig into the details, but the most important ones are the files inside output bins. So here you can see we have 4 FASTA files. Each one of these corresponds to an output, to a bin. We also have this bin info. If I open it, so here's the outputs, and then a little bit of information about it. So, the number of base pairs. So this is 300,000 base pairs. Probably not a complete genome there. Just saying. This one is 4.4 million. So this probably is a complete genome. This number of contigs and 50 and L50. So it's just some very basic statistics. But obviously, normally now you will be running, something like GTDB-TK or Checkm and those kind of tools to get more information on your bins. Right. So yeah, that's it. So if all you want is to get bins without too much trouble, here, it took 30 seconds. Maybe in a real data set it would take a bit longer, but we're talking about, a couple of minutes, not much longer. This would work. Right. So here we use this easy mode, which does everything. I'm just going to show you, that you can also run step by step. So for example, here I am going to be, so if I run this other subcommand, generates sequence feature single, it will again takes the same input FASTA, same output, and same inputs FASTA and BAM. I tell it which directory to output, and now it's going to write these data files for me. So actually, let me do it. So in this case, I'm just going to do a new one so that there's nothing else in that directory there. So if I show, see, right? So there's this log file is always there. So this is basically the same input that you saw on the screen. It just saves it for you. So in case, mostly for debugging purposes, really. And then it created these data files, data split. So these are really useful mostly for internal purposes. And then the next thing we could do is we could train the model. So we could use this to train the model. And I'm going to add even epochs 1. So what this is now doing is SemiBin is a machine learning system, so that it has to train a model, which takes these data CSV files. You tell it where you want to output the model. And in this case, I'm also telling it that I want to run a single epoch. A single epoch is a single training loop. And it's a very, very bad idea because the model will not be very good, but otherwise we would be here waiting for it for a very, very long time. In fact, we are going to be, this is going to take a while. So what I'm going to do is I'm going to pause the recording and I'll be back in a couple of minutes to get back to you. And welcome back. So we're done. So this here, you can see the timestamps went from 18 to 31. So it took about 15 minutes to run, more or less. And yep. So, and now this will have output this model file, which is a file that you can now use on the same sample or on other samples. So if you have data that's coming from one of the environments where we already provide a model, so for example the human gut, and one quick way to check is so for example here. So for example here, instead of the human gut, let's say we are so outer space. For example, there's no model for outer space, but it will print out that, so there's human gut, dog gut, ocean, soil, cat gut, so etc. And so those, we do recommend that you just use them instead of coming up with your own. In that case, why it's that case? So right, so let's go back to the, so now we've trained the model, and now we can use the model. So we can just call bin short. So using the model, so here we're binning short because we use short reads as opposed to long reads. And so say you give it the model file that we just created, the data file, we give it the FASTA file again. So we have to, and we say, we want the outputs to be in this single output directory. And in this case, well, it complains that the output directory already exists. Normally you would not be running and rerunning this many times, right? But that's it. So now, so as you can see, training the model is really the only step that takes a long time, which is why we've first of all, we provide these pre-trained models. And the second thing, and this is important, is even if you have a new habitat, completely, outer space samples, and if you have many of them, you don't need to train a model for all of them. You can train a model with a subset and then use that for the other one. So you only pay this computational cost one time. So that's it. So we did here bin short. I mean, you can also guess that there's a bin long version, which we use for long reads. So most of the pipeline is actually the same, but at this step, this long read clustering is slightly different because when you have long reads, you have long contigs, and when you have long contigs, you can have the thing is your bins can be quite small in terms of the number of contigs that they have. You can have a bin with a handful, literally 5, even 4 contigs. Sorry, you can have a bin with a very small number. And so we had to adapt the algorithm to take that into account, right? And so here apparently maybe we can gain some efficiency. This is new. This was not, we didn't get this before. It's interesting. All right, but that's not the topic for today. Maybe the last thing I'll show is that, so we did start by using the EasyBin, and then I showed you how we could do all of this, and we can, so if we were using if you're using long reads, we would just have to say that sequencing type is long reads. And I think this, I even spelled everything correctly. So the single mode, this easy mode, the single easy mode, all it does is internally it will run all of the steps. So it will generate the features, and then it will in this case not train the model because we say use a pre-trained model and then run the binning exactly as we could have done in multiple steps. So by saying it defaults to short reads, I think it's still the case. That's what most people have, but just to be sure, if you can just use this sequencing type long reads to get this running. So that's it. So I'm gonna I only have one screen, so I have to play the outro music by switching windows. Yeah, so we're very open to comments. There's a SemiBin mailing list. You can just comment below. You can show up at office hours if you're watching this soon after I post it. So April 24th and May 9th. Links are also in the description. So with that, I hope to talk to you soon.